So I'm Vikas Gera. I run my own training and consulting company called Thought at Work. I'm a mechanical engineer with an MBA in finance and marketing. There's a little typo there. It's from Birla Institute for Management Technology, BIMTech, which is in Greater Noida. I have worked with many companies like Carrier, Whirlpool, Hewlett Packard, and WNS in quality operations, Lean Six Sigma roles. Um, Not only in India, Asia, but also in Europe and Americas. I have implemented Lean Six Sigma across the globe in 12 countries. I always like to do, that's what my clients tell me and my customers tell me, that because you think out of the box, you challenge the status quo, challenge the setup. So I guess Lean Six Sigma is something I'm very passionate about, because that gives me an opportunity to really improve operational efficiencies and effectiveness of any any setup, any business process, any industry, because this is a methodology which can uh, which is irrespective of which industry you work in. Every industry will have some quality goals, quality targets, cost targets, service delivery timeline. There are SLAs. So whether it is manufacturing or services or pharmaceuticals or any other industry. Even in last class I was teaching people from investment banking vertical as well, also risk management people. I was also teaching Lean Six Sigma. So they all kind of feel it's something they need for their day-to-day job, because now there's so much of competition that all jobs need you to not only work on day-to-day deliverables, they also expect you to do projects, they also expect you to do improvements, and Lean Six Sigma is a methodology which can help you do that. A little bit background about me. I was the first one in India who implemented Lean in consumer durable segment. I was also first one in the world when Lean Six Sigma was applied in business processes. I was incidentally lucky enough to be in Hewlett Packard at that time, and I was able to do those implementations starting from India and then took it to the other countries. So we'll start with what is Lean Six Sigma. What is Six Sigma, right? Because many people ask me this question, because why we call it Six Sigma? Okay, why not something else? What is in the name? Like we all say. So so this is basically, when we say Six Sigma, what we actually mean for the practitioner is that we want to bring in the quality of this, whatever setup, whatever business we are applying it, to 3.4 defects per million opportunities. So you all know what 1 million is. Normally, when you have seen quality earlier, before Six Sigma came into the vocabulary of quality people, it was always known to be, quality was expressed in percentages, right? We used to say you are 99% accurate or 98% accurate. There is 1% defects or 2% defect. That's the way we used to mention about quality. Now when we are looking at post Six Sigma, we actually started talking quality in terms of per million opportunities. So when we say per million opportunities, obviously we will not going to cover all that, but per million opportunity means is each product which you are manufacturing or each service transaction which you are doing, whatever transaction you are in, whichever industry, there are opportunities to create an error. So for every million opportunities, you will only have 3.4 defects. That's what actually it signifies. What we do is Six Sigma focuses on reducing variation. So any variation and each process, believe me, will have variation. There is no process in the world so far which I have seen which does not have a variation. And you know what is a process. So process is the way of getting things done. So you will be working in different functions, different department. Maybe at the end of this webinar, if I'll have some time, I'd like to get to know about you. but whichever function you're working in. So when you're asking any question, please introduce yourself as which company you're working in, which function you're working in, what role you're doing, so that I can kind of answer it more specific to your function or your organization, your industry. So all industries, all processes will have variation, and Six Sigma helps you to reduce those variation. And why we want to reduce variation? Because and when we reduce variation in a process, the process gets better, the quality gets better. It's just like you're coming to your office, say 9 a.m. in the morning. You may come at 8:50, you may come at 9:10, you may come at 9:05. You're not coming always at 9. But the more there is a chaos on the road, there is more traffic on the road, there are more red lights, so you will realize someday you're reaching your office at 8:45, another day you reach your office at 9:15. So you're kind of getting unreliable. So what will happen is, the more variation you will have in your commuting time, you cannot plan your work. So if someday you reach at 9:15, someday you reach at 8:45, so what is expected is, can we reduce this variation so that you reach office at 9? Because then you can plan your things. Okay, so this is what Six Sigma helps you in. It's a Greek word, right? Sigma is a Greek word, that's why it is represented by that Greek letter sigma, as you can see on your screen. It talks about the spread, so we will not have cover this, but when you will go to the course, you may have been familiar with a normal distribution curve, which actually there are different kind of distributions which you will read in your stats. So the bigger the variation, the lesser is the sigma. The more are the defects. So it talks about the sigma, talks about how much of the variation is there in the process, and it goes beyond defect reduction, right? It more talk about the business improvement. So defect looks to be very quality specific thing, right? Okay, we are talking of only product quality or service quality, but when we say business improvement, then it encompasses a bigger thing, right? Then it talks about your R&D process, it talks about your supply chain process, your sales process, your finance and accounting process, your strategy process, even your business planning process. So all of that we can apply Six Sigma in any business process. Okay, it applies to be cost reduction. You can also apply it for revenue enhancements. You can apply it for cycle time improvements. You can apply it for customer satisfaction, or for that matter, employee satisfaction, even reducing your attrition, right? Any metrics which is important for your organization, you can apply Six Sigma. This is an interesting slide where what I share with you is um, what all things you can do with Six Sigma. You can use it as measure of consistency, which means how much consistent your process is, which is necessary. What I was talking about, the spread of the normal distribution curve, which means the variation in the process. Six Sigma is also can be used as a measurement system. So whatever metrics you have, you can all measure them in the Six Sigma way, right? So if I ask you what is your quality level, you can tell me it is 4 Sigma, 5 Sigma, 3 Sigma. You can use it like that. Six Sigma is also about a methodology which is around problem solving. So you have heard of many other problem solving methodologies. The popular one are PDCA, Plan, Do, Check, Action, which was given by Deming. Another problem solving methodology is what we call as Zuran spiral, which means PDCA, implementing again and again. You kind of go in a spiral mode. And then we will talk about two of the methodologies in this class, but we'll focus more on the DMAIC. But I'm going to share that you in the next slide. It's a disciplined way of doing things. So Six Sigma also gives you a structure. It also gives you a discipline. I remember when we are doing projects, people tend to skip certain steps. Six Sigma methodology does not let you miss those steps. In my last green belt class, which I was taking here at Edureka, there was a student who wants to now do a project and get certified. And I was telling him that you shouldn't be missing about any steps in your project, because important is not to do a project, important is to do it right way also. Because if you don't do your projects in the right way with the disciplined approach, the chances are your problem may reoccur, okay, or the problem will not get resolved. Six Sigma is also about business strategy, because Six Sigma works with the very senior management. You have a top-down approach as well as a bottoms-up approach. So it kind of can be very closely worked with your strategy. I'll move to the next slide. Okay, so we want to all understand how was the journey of Six Sigma, where it all started, right? So this slide tells you about where all Six Sigma was started. So it was somewhere around mid 1980s. There was a guy called Bill Smith, who is now known as father of Six Sigma. He was designated an in-house model for reducing defect. So at that time, Motorola used to have a chairman called Bob Galvin, and he liked that model too much. He said, why can't we implement it across all sub-function? And that's how the Six Sigma was implemented first time in the world. Later, what happened, Motorola CEO, the chairman, was talking to Allied Signal chairman, who was his friend. It was almost 8-10 years later when he actually did that. And Allied Signal came to know about how Six Sigma Motorola has implemented, and he copied from there, right? We always say beg, borrow, steal. Whenever there is a good thing which you think should be implemented in your organization, in a function, so just go ahead and do it. So it went from Motorola to Allied Signal. Later, Allied Signal, management, they were friend to Jack Welch, and he hired someone, I guess, from Allied Signal, or they kind of were friends, where it went to GE. And now GE being the market leaders at that time, they were struggling with their product lines, they were struggling with their whole cost, and Japanese were giving competition. Jack Welch actually used it very, very effectively in GE. He actually, so G, if I say which organization is being accredited to really spreading the Six Sigma, I'll say G, not say Motorola, because Motorola might be the first organization who implemented it, Allied Signal might be second, but G was the one who actually harnessed the whole beauty of Six Sigma, or the power of Six Sigma. So in next 5-10 years, G was implementing it. G still, it's part of G DNA. Now there are close to 129 organizations who are applying Six Sigma methodology extensively across the world. What I show by this graph down there is the whole journey of the quality methodology. So quality, Six Sigma is not just quality. Six Sigma, if you see in the whole quality journey, which started from 1800, now we are sitting in 2015, it's almost 215. So since the time the industrialization has started, quality journey has started, because you can't think of producing something with defects, right? So there would have always been pressure to the manufacturers of products and or the industries to improve quality. So what you see is the gauges were discovered in 1840. The concept of interchangeable parts came in during 1800. Then the concept of no-go gauges come in. So those of you who are not familiar what is go gauge and no-go gauge, are you from manufacturing by chance? Anyone? Can you just put in your questions? Can you tell me if there's anyone from manufacturing here? Oh, you have the dialog box? Okay, anyway. Oh, yeah, I saw in IT now, but I graduated in production engineering. Okay, great, Amul. So, yeah, so you may have read about your engineering go no go gauges. So these are just when you're producing parts and manufacturing, you want to really make sure that you only produce good parts, and there should not be any bad part which goes next to the assembly line. And what happens is, I'll give you that the concept of World War II, right? 1945. So what was happening in World War II? that there were American soldiers who were fighting on the with the German soldiers, right, on the border. And what was happening is the bullets they were getting from their factories, the defense factories, they were not produced to the right size. Now, since they were not produced to the right size, when they were putting those bullets into their guns, they were not able to fit into the guns. So they used to try the bullets on the war front. And what was happening, there was a bullet coming from the enemy side, and by the time he was trying the bullets, the right size bullet, he was already dead. So there were a lot of people who died, and then suddenly they realized that we have to apply go-no-go gauges. So go-no-go gauges, actually, if you see in this graph, were from 1840, 1870. But surprisingly, from 1840, 1870 till the World War II, which was around 1945, almost 100 years, this was not being used. Can you believe it? How yeah, industry works. People, we have some invention or discovery, and people really don't realize the benefit of that. And that's what actually is happening with Lean Six Sigma also. We know they're good, but how many organizations seriously are doing it? And that actually tells about how the corporate works. But then World War II, they realized to use go-no-go gauges. So before they were sending bullets now to the border to their soldiers, they were actually testing them with go-no-go gauges, which means there was some kind of for a template or a shape, a mold, where they used to insert bullet as they are inserting into the gun. So if it is loose, then what it is required, then it is rejected. If it is tight, then what is required, it is rejected. In both the cases, bullet is waste, and then you can waste a soldier's life in there. So this is the importance of go-no-go gauges, where they can check before the use of that part. Now that is something which is part of all manufacturing processes, and even in transactional processes in non-manufacturing, they have been implemented. Then the Zuran came in, you know that Deming and Zuran, they were the one who actually took this quality from US to America to Japan. They were Americans, but they were so popular in Japan. And people say American industries did not appreciate their work, but Japanese industries, they wanted them back. And the whole story of Toyota and the whole Honda and everything, actually they were the one who actually helped revive the Japanese industry. Okay. And then the Phillips Crosby came in, who came up with the concept of zero defects, or the famous book of Phillips Crosby called Quality is Free. And after that, I guess the total quality management movement started, which we call as TQM. And then Six Sigma came somewhere around 1987, as you can see, mid 1980s. Okay, this is the whole history. This is a famous quote by General Electric CEO Jack Welch, who says Six Sigma is the best training that an organization can give to its employees. It's even better than sending them to Harvard Business School. So he actually compared Six Sigma training directly with Harvard Business School. So I'm sure Harvard Business School will never like it, but that's what Jack Welch told his people, that if you really want to become business good people, good business employees, want to serve your company, then before you go to Harvard, learn Six Sigma, because you can do a lot by learning Six Sigma. Now this is a comparison chart, very interesting. You may have seen it before. Some of you, whenever we're talking of Six Sigma, we always show this chart. So I will show you what you see on the left is the classical view on quality. So when you are actually measuring quality in percentages, when you say 99% quality level or 3.8 sigma, if you convert that 99% into Six Sigma. So what 99% quality looks very good, right? To all of us. Oh, you're producing 99% good products. Very good. Only 1% is bad. When we apply Six Sigma, we go from 99% to 99.99966%. So obviously anyone will tell me, Vikas, this is much better than 99%. But then when you're doing 99.99966%, then only it becomes Six Sigma. So you can just see the journey from going 3.8 sigma to Six Sigma actually means a lot to your product quality. Now I want to show you the business impact of that. If you see the first line where my mouse is coming in, when you are 99% right quality, what it means is that you will have 20,000 lost article of mails per hour. Okay, so if you are into a mail business, courier business, if you have X volume, this is what it means in terms of absolute numbers. But if you are 99.99966% or Six Sigma, you actually mean only 7 article loss per hour. So from 20,000, you go down to 7 when you move your quality from 3.8 Sigma to 6 Sigma. Now let's see some more example. If you are into a water distribution business, right? You're kind of a jal nigam, right? That's what we call here in India. And then you're supplying water. It means you're going to supply 15 minutes of unsafe drinking water every day, which means every 24 hours you supply 15 minutes of unsafe water. But when you go to Six Sigma, it just means you have one unsafe minute of unsafe drinking water every 7 months. So suddenly from 24 hours you become 7 months. So you see the quantum jump which you are getting in terms of your quality. So if you are a doctor, if you are in a hospital business, what it means is 99% quality is 5,000 incorrect surgical operations per week. But if you are a Six Sigma, what it means is 1.7 incorrect operations per week. So suddenly you're going from 5,000 to 1.7 only. Can you see the jump? I think this is important, very important to emphasize the importance of Six Sigma metrics. How does it help? If you are on a flight business, the airport business, it means too short or long landing at most major airports each day. So flight coming in every day, you're going to have too short or long landing. Short or long landing, you all understand, which is like not at the right spot, right? But when you are applying Six Sigma or you are a Six Sigma quality, it just means one short or long landing every 5 years. So from one day you are suddenly jumping to 5 years. That is the kind of quality you are going to produce. Now talks about the insurance policy. If you are at 3.8 Sigma, 99%, it means 600 new insurance policy per month delivered with errors. So every month you will have 600 policies new which will have some error. But when you are at Six Sigma, you will have only one new policy delivered with error, and that too every 5 months. If you are into a telecommunication business and you are at 3.8 Sigma, 99% quality, you are going to be having 1,80,000 lost calls each year, which will be only 61 lost calls each year when you go to Six Sigma. And then last one, there's no electricity for almost 7 hours each month. If you are using electricity 24 hours a day, out of 24 hours uh, every month, so 24 into 30, say 720 hours, you are not going to have electricity for 7 hours. But when you are going to Six Sigma, you will have only 1 hour without electricity, that too every 34 months. So all this comparison I'm sharing with you because that gives you the impact of the scale of Six Sigma. I'll move to the next slide, which talks about, okay, I have some question here. Oh, these examples are very real, Dinesh. These are examples which are, they're not from India for sure, because I am seeing these examples for many years before we started even Six Sigma journey in India. So these are examples from US and they are real industry examples which we are sharing with you here. They're no imaginary example. So they are comparing one industry where they've taken these examples and then they're saying how that will impact the business outcome when we go from 3.8 Sigma to 99% to 6 Sigma. I hope that helps, Dinesh. Okay. I'll move into the next slide. So what is the concept here behind Six Sigma methodology? Okay, there's no business who does not have any problem. I have still to see a business who have a problem. Okay, because so many differences in 9.96. Yeah, Dinesh, these differences coming. So let me tell you, I think many of you are amazed. Dinesh is amazed with these examples, and I can totally relate to where Dinesh is coming from. Many of you are seeing, okay, how does this changes 20,000 to 7, or 5,000 incorrect operation to 1.7? This is not a linear scale, Dinesh. So 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, and 6 sigma, they don't operate on a linear scale. When you have a linear scale, then you expect, okay, change in one will result into change in whatever same scale in there. Six sigma is not a linear scale. So initially improving quality will be easy. So for example, going from 1 sigma to 2 sigma may not mean the same thing as moving from 4 sigma to 5 sigma or 5 sigma to 6 sigma. Is it clear to everyone in the class, in the webinar today? Okay, this is not a linear scale. So when I say 3.8 sigma to 6 sigma, it does not mean the same when I will say 2.8 sigma to 4 sigma. Okay, thank you. Thank you, Dinesh. So I'll move into the next slide. Yeah. So what Six Sigma works on is that there is a business problem you have, which your leaders understand, which your managers understand, which your CEO understands. What a Six Sigma green belt, black belt person does is convert that business problem into a statistical problem. Okay, once you get that statistical problem, because statistical problem will be something in numbers, right? You can talk of numbers. Okay, from 50 hours per this I have to go to 20 hours. Okay, or from 10 20, just like previously we have done. Then the statistical solution will find a statistical solution. So when I mean statistical solution, so we will hypothetically work on, okay, if you have to improve quality, then this number should come down or this number should go up, whatever it is, right? You may be working on improving your uptime, which is reducing your downtime. So you can have both objectives. You can have an objective of improving your uptime of your servers, of your machines, of your transactions. You can also have a target of reducing your downtime. And then you will have a business solution, which is nothing but telling, okay, this is a problem I have, and what is the solution I will give it here. So you actually have to give you have to convert the statistical solution into a business solution. What it means is that should be practically possible to implement, right? We just can't have it on an Excel or on a Minitab, what we use as a statistical software. Okay. Now this slide talks about two famous methodologies which we have for in Six Sigma. One is called DMADV, and second is called DMAIC. Okay. So I'll little bit explain you which process or which methodology is used in which kind of scenario. So if there is already a process which exists, right, then you will actually may use DMAIC or you may use DMADV. But when the process itself does not exist, which means when you're doing something for the very first time, process will never exist when you're doing something for the very first time. In that case, you will do DMADV, which stands for define, measure, analyze, design, and verify. Okay, so this design and verify is the what changes when you're using a DMADV, because you're designing here, because the design is already not there. But when you actually are going to use the DMAIC, which means the design is not required. As you can see, the process already exists and design is not required, then you will use DMAIC. So DMAIC stands for define, measure, analyze, improve, control. So this is more like an abbreviation for the methodology we have. So this is how we use. I'll go to the next slide. Yeah. So in Six Sigma language, you will always talk about X and Y. Okay, now what are these X and Y here? So X and Y are why we signify or it signifies the effect. You know cause and effect. Okay, so there is a cause and there is an effect. X signifies the cause here. Y signifies the effect. So Y is always an output of X. If there is no cause, there is no effect, right? That's why we always give this equation as Y is equal to function of X. That is how we tell it. Okay. So Y is a dependent variable here, which is more like a symptom. Okay. And X is an independent variable, which is more like a problem. Okay. Output is what you have to monitor. So Y will be always an output. You will only monitor it. X is more of an input or part of the process which you can control. Okay. I'll give you an example. This looks little confusing for people who are hearing it first time, but I'll give you an example. Okay. So I say you have to come to office in time. So what I actually mean is if your office starts at 9, you have to come to office at 9 a.m. So what is 9 a.m. here when you're coming to office? Can someone put it in the question window? What do you mean by 9 a.m.? Is it an output or an input? Is it Y or is it X? I will say come to office at 9 a.m. Some of you are saying input, some of you are saying output. Okay, those who are saying input, I'll ask them how that is an input. If you have to come to office in time, that is an output expected out of you. So what time you start from home should be the input, right? Can you come to office in time if you don't start from your home in time? Okay, now Abhishek, yeah, Abhishek. Everyone is saying yes, it's an output. Okay. So when I asked you, it's just like I want you to score 70% marks in your exams. Will it be Y or will it be X? From you, it will be Y. Output, right? That's the marks. That might be input for your competitive exam, right? If you're sitting in or you are trying to get admission in one of the colleges, then that output of you will become input there. So let's not confuse. Every output is an input to something else, which I understand. But when I'm talking of the scope or the boundaries where I say I want to really observe you as how good you are, for me your output is your marks. So what will be the input here for getting say marks 80% or 70%? What will be the input here? Number of hours, yes. How much preparation you are doing, how much of studies you are doing, how much of questions you appeared, how much of chapters you read, all of that will become your input. So you understand the difference between output and input, right? If I expect you to come office in time, then your start time from your home, which vehicle you are using, are you using a car or a bicycle, or are you walking to your office, or are you jogging to your office? All that will become your input to the output, which is the getting office in time. So this is how we do the defect density, the SLA met, the response time. These all are output. Okay, what is the input is number of requests delivered into the SLA norms, time the ticket was raised by the client. So everything which results into that output will be called an X. Okay, so what you control in a process is X. You can't control Y. Okay, there are many people who don't understand the difference between Y and X, and they fail to improve processes because they focus on the wrong metrics. If I only look at the metrics of what time you're coming to office, will it help me to improve your arrival time in office? The answer is no. I can only know by looking at what time you're coming to office. Only thing I can come to know is whether you're coming to office in time or not. But if someone asks or rephrases the question or asks me, Vikas, Mr. X is coming to office 15 minutes late every day, I want you to help me understand, help me diagnose why and what we can do to help him to come to office in time. Now I can't really do that, you know, just by looking at your time. Okay, I have one question. Let me take that. It says, can you please explain defect density and defect size is related to Y and X? Okay, okay, okay. Defect density and defect size. I'll explain you. So defect density is, I say, 20% of the people in this group are not. So if I say, def- so let's define the defect first, right? So the defect can be anyone who is not taller than 5 foot 5 inches. I'm not going to select him for the armed forces, okay? Or I'm not going to select him like for an air hostess in a flight, right? That's my minimum criteria. So anyone who is less than 5 foot 5 inches will be a defect. So that's my defect density, right? Now I can't really improve, as I was telling you, this process, that you are actually less than that within that. So now the defect size will be the, what is your upper control limit, what is the lower control limit, what exactly, how much. So you may have to look at here the diet people are having, what kind of genetics they have. So there are some people who have genetics where they are going to be, longer than others. So you have to look at those metrics which you can control in here. That's what you will call as defects, right? Which might be, so I have to really look at, I may not be going to a particular region, I'm not going to go to a particular class, I'm not going to go to a particular age. All that will be counted as defects. So when you have to improve your ratios, another example I can take is your service level. Okay, you will say I am not able to process in whatever transactions you are having. 92% of the transactions I'm not able to process in time. Now, this 2% of the transactions you are not able to process in time is your defect density. Okay, but if I ask you, tell me I want to improve this, then you have to go from defect density to actually understand the defects. So I'll say, tell me what those 2% are, and then you can tell me, okay, let's look at one by one those cases which are 2%. And then I realize, oh, this transaction only came in the Saturday Friday evening in the third shift, and then Saturday Sunday we had off, so I was not able to meet the cutoff time of 24 hours. Now I was able to process it on Monday, but then it shows in the time arrival that it came on Friday and it was processed on Monday, which means 4 days. So there's a wrong expectation I have from this. So this is when you say, yeah, I think SLA means service level agreement. Yeah, SLA is service level agreement. So those who are into IT world, they know that this is a common terminology we use. Just like manufacturing, they will have quality data. Here you measure everything as a service level agreement. Thank you. I'll move into the next slide, Abhishek and everyone. So we'll go to who is using Six Sigma. Okay, we need to also look at that. As I was telling you, Six Sigma is an industry independent methodology, which means it has been used across all industries. We have mentioned few of the industries where it has been used. It is automotive, aerospace, health equipment, FMCG, electronic goods, continuous process industries, textile, all of these are where Six Sigma has been deployed. Also, it has been used in the service industry. So those who are in service industry here, like telecom, banking, financials, I have applied Six Sigma and Lean both in services and in manufacturing. So I can relate to uh, how differently it has to be applied when we go to banking and financial services or ITS or KPOs. It has been applied in support services, HR, marketing, or even R&D organization. Uh, we will spend some time here on how organizations get benefit from Six Sigma. If you look at this, uh, it can help organization produce products and services better. Who business owner will not like to improve its want to make product which are better, faster, and cheaper. Everyone wants better, faster, and cheaper. So uh, it helps us to go there. It also removes wastages. It maximizes the customer satisfaction, increase sales, maximize product service quality, get close to zero defect, improve overall organization productivity, saves cost, blah blah blah. You can just read it. All these things are reality in case you really understand this methodology and can apply it. I'm sure in your respective organization, you may have a culture of Six Sigma and you may be using it, but if you're not using it, it's a great investment you can have for your uh, for the people because they learn a new methodology, as well as for the organization because what they learn, they apply and improve the product and reduce the cost. I'll show you some names, some organization who have applied it and some of the benefits they've got. So the biggest one here is GE, which has benefited around 2 billion US dollar. 1 billion is close to 6,000 crores Indian rupees if we convert that. So 2 billion will be around 12,000 Indian rupees, 12,000 crores of Indian rupees. GE was the first company who applied Six Sigma in services and offshoring. Motorola reduced in process defects by over 300 folds, 300 times, which results into an $11 billion saving. So it's even bigger than GE, right? Um, you can count $1 billion is 66 rupees. The last I kind of remember. So 6,600 crore rupees multiplied by 11, which is 66,000 crore Indian rupees. That's the saving Motorola has got from Six Sigma. Airtel India has got 250% ROI in the first year itself, which means if they invested 100 rupees, in Six Sigma, they actually were able to recover it 250% of that within the first year. LG has also saved around 850,000 US dollar, and Qualtech has saved around 20 million US dollar. These are some of the users of Six Sigma. You can see all the big brands, all the big companies. I've worked with a couple of them. Some of them are my clients, and I can vouch. This actually is remarkable and very impressive. Okay. In this slide, what we show you is the total comprehensive saving for not only GE and more, some other organization also, JP Morgan Chase, Texas Instrument, Johnson and Johnson, Honeywell. We have taken these numbers from their website, very authentic. Little bit I can talk about the course, the Six Sigma Green Belt course, which we have at Edureka. I am one of the facilitators there. There are more people who come and teach you these courses. These are live online classes, so which means I'm going to be, or someone, an instructor like me will be here who will be taking these online class, which will be live, which means you can ask questions just like you're asking today. It is going to be very interactive. We have some quizzes which we do module wise. You'll have question and answers. We have also these recordings. So suppose you miss a class, you can actually go to you will have a login password. You can go to the learning management system and look at your class recording. So suppose you have skipped 30 minutes of my class, or in the beginning or in the second half, you have to go out for somewhere, you can actually see the recording later. You have 24/7 support for this class, so there will be someone from Edureka who will be supporting you for any query you have or any questions you may have. They normally either answer those questions themselves or they refer it to me in case it is related to the course content or something which I have to help you out. So that's the how interaction works. We also will give you project work, which you can pick project from your respective organization, and we are going to really help you during the course. And at the end, you will get a certificate, which you can use for your own reference. Okay, I have a question here. Okay, let me see that. Okay, so this is Abhishek, I guess, again from the quality assurance, software quality assurance. Okay, Abhishek, can you please expand on how to move from, for example, 3.6 sigma to 3.8 sigma to 6 sigma? Is it dependable on the level of DMAIC or DMAVD method depth? Yeah, that's a very good question, Abhishek. Um, okay, so DMAIC and DMADV are the two methodology which are be used for improving quality. Now there is a design quality. So first of all, you have to see what is the best quality you can achieve from your current process, which is you will be using DMAIC methodology and you will be improving your quality. Many times I've seen the design itself is not right, and that's a fact that when you're designing product, you're not designing it for Six Sigma, which means there will be some inherent defects which are built in. In that case, you have to use DMADV and you have to redesign your process or redesign your product or redesign your service level. In that case, you have to also use DMADV in case you have to achieve Six Sigma. So I don't want to pretend here that every time by only using DMAIC, you can take your product quality from 3.8 sigma to 6 sigma. That may be the case, that may not be the case. But if that is not the case, then you have to also apply DMADV. Does it help, Abhishek? Okay, I'll move to the next slide. I think that's almost the end of the webinar. So I can take your questions now. We have got almost 10 minutes available with us. And you can ask as many as questions you want. I can take them one by one. You can type your questions in your question window. Can you explain how ppm is calculated basis Six Sigma? Yeah, I can tell you that. I think there's a formula for that. We will be taking that up in the class. Uh, Let me see who has asked this question. So this will be part, Dinesh, this will be part of the class when you will enroll for the course. But there is a formula for that in Excel as well as on the Minitab you can do it. And before the Excel and Minitab was there, you could have still do it. There's a way to do it. Then at that time you used to spend a lot of time in calculating it. There is no software which can actually convert. It is HIMA, I think, HMA, SANI, okay. There's no software which can convert a business problem to statistical problem, but there are software which can actually help you solve a statistical problem. Minitab is one of those softwares which we use in our class. But business problem to statistical problem requires you to apply your business knowledge and then convert it into a statistical problem. So there's no software for that. Any more questions? No questions, no confusion? If you have any questions, please tell me. Okay, I have a question. Okay, 1 second. I have deleted one question. Can you type it again? I was just deleting what I am answering. So I by mistake deleted one question which I haven't answered. Okay, I have one question which says, how is this cause and effect thing um, related to Six Sigma? Okay, cause and effect is not only for spiritual thing, huh? Uh, it or the Newton's law, right? Cause and effect. It is also related to Six Sigma because we believe in that if you have a bad quality, bad output, it is because of some causes into your process. Okay, until unless you understand those causes, you cannot improve the quality, and we call that as causes as controllable. Like the example we just took in today's webinar, if I want the effect to be distinction in your exams, then the causes which will cause that distinction will be your aptitude towards your study, your passion, your motivation, your number of hours you're studying, all that will become your causes, and even your family atmosphere, even what kind of support and help you get from your parents, from your teachers, all of that, right? So that is how the quality improvement happens when you focus on the causes, because causes are the one which you can control. You cannot control the effect. Okay. The certificate given by the Edureka is globally accepted. Okay, this is very tricky question, right? Okay. Um, I think I'm not sure if we are doing it from IASSC, but yes, we have plans to do that. I was talking to someone in Edureka where we have plans to get this certificate from IASSC. Um, I'm not sure if we already started that, but you see, I personally am not a person who will go for certifications until unless it actually helps you solve your business problem. Edureka itself is a big brand, and certificate from Edureka, Lean Six Sigma Green Belt itself should be good enough for you to take it to your employer and tell you have done this course. Moreover, you can tell who is your facilitator. But you know, if you don't solve business problems in your organization, whether you get a certificate from IASSC or you get from AQC or you get from IQPC or for that matter IEEE, anyone, it will not help. People will only regard you if you actually solve their problems. Okay, so your boss will only respect if you are able to help improve your work area. So your focus should be more on improving the work area, solving business problem, and then any organization, whether it is Edureka or IESC or anywhere you get that certificate, so they will be recognized because of you, rather than you will be recognized because of us. Right? I'm an alumni of Birla Institute, and I go to my college. They always call me to address the students there. And I always have this question: is college known? Is IIT because of the students, or is that students who have made IIT and IIT? Right? Suppose you have done your engineering from IIT. So I always believe in it is the students who make IIT and IIT rather than IIT makes its student. Okay, that is what I mean. So don't worry about the where you get the certificate. What is important is, have you learned the methodology? What is important is, have you used this methodology and solve some of your problems in your organization? Okay, I have some more questions. Bipasha this side. Okay, Bipasha, I work with Hiram Ampus, part of Nokia. Okay, we have quite few quality measures. Can you tell us what is the major difference between Six Sigma methodology versus Kaizen, or both are entirely different? Okay, so I think this answer is very simple. Kaizen is a different methodology. We teach also Kaizen when we are teaching Six Sigma here. So Kaizen will be part of the curriculum. Kaizen is a work culture improvement, the small problem solving thing. In Six Sigma, you are actually learning many different tools. So Kaizen is simple, but simple does not mean it is not effective. Kaizen is very effective when it comes to solving problems on the shop floor, when it comes to creating a quality culture. For that, Kaizen is very helpful for the improve phase. But Six Sigma, will be more used for solving some problems which can't be solved by Kaizen. That's where you will apply Six Sigma. So anything which can be solved by Kaizen, I'll say go ahead and do it. That's more effective. But if it can't be solved by Kaizen, then I'll say go for a methodology which is more, which can address the complex problem solving. So Six Sigma, for that matter, is used for a little bit more complex problem solving. Okay, can you differ between Six Sigma, Kaizen, and Poke-Yoke? Yes, Dinesh. Poke-Yoke is a name given for mistake proofing. Okay, Kaizen is a name given for small improvements. Okay, and Six Sigma is again a different structured. Either it can be DMADV, it can be DMAIC. So that's a different methodology, right? So all three are different. When you're using Poke-Yoke, then you're trying to avoid mistakes. So gauge what we use, go no go when I'm telling, I think are used. For example, I think there are many examples of Pokeyoke. Your ATM card, when you're inserting, it does not let you insert in any wrong way, right? If you insert it wrong way, it will not accept it. That's more like a Pokeyoke built into your credit card. Um, Kaizen will be small improvement, so it is like a small work improvement team. People on the shop floor, they have some breakdown. There is some absenteeism, and any day they work on small problem solving. They don't need much of help from senior management. They don't need much of help on statistical tool. That's what we call them as Kaizen. Okay, I have one more question here. Where is used DMADV? Okay, which area? So DMADV is normally used to design. Whenever it comes to a new design, you use in DMADV. But when I say you will use DMADV whenever there is a new design, doesn't mean I'm saying you have to use it in R&D. Okay, when I talk of new design, people just say, oh, R&D. It is not R&D. You will have one of the R&D person as a part of your team, or you will have one person who is into process design as a part of your team, but it will still be applied on the shop floor. And one question someone asked earlier in this webinar, where he asked me, can I go from 3.8 sigma to 6 sigma only by using DMAC? And I answered, many times you will, many times you will not. In that case, you have to apply DMADV. So to answer your question straight, you can use DMADV in any area, okay? Any area, any business process. When you think with the current process, you cannot achieve your Six Sigma level, then you will apply DMADV. Does it help? Okay. Any more questions we have from the class today? Karishma, Rashmi, Sankalp, Dinesh, Biswajit, Vipasa, I think you asked question, Arun, Amul, Valeria, Abhishek. Abhishek asked questions, yeah. Any more questions we have? Okay, I have one more questions. Design and verify means about what function in R&D? Design and verify, okay. Okay, so it's not research and development function. So here we are not talking of design and verify of your main product of your company. So if you are in Nokia, I'm not saying design new Nokia phone here. What I'm saying is for any part of Nokia organization, if you are applying Six Sigma, you have to sometimes redesign the process. So where we are saying design, we are talking of redesigning the process, not necessarily redesigning the product. And I'm not saying you will not redesign the product, but when you have to redesign the product, then this DMADV will be used by your R&D team only, not by you. But when you're redesigning the processes, then you can do that. Whoever is the process owner can do that. Does it answers your question, Dinesh? Okay, thank you. Thank you very much, guys. I think my last take will be do this course in case you enjoy solving problems. Okay, in case you like taking challenges, please do this course. This is going to be very helpful. Thank you very much, Dinesh. Thank you very much, everyone in the class. Thanks, Abhishek. Thanks, Dinesh. Thanks, Bipasha. Thank you. Thank you. Thank you. Thank you. Yeah, I'm going to close the class now. Have a good day, good night from whichever part of the world you are. Thank you.